Hello all, welcome to episode 5 of our ROS series. In the previous episode, we created our ROS2 workspace called YT_WS. But an empty workspace cannot do much yet. To actually start developing robot software, we need packages. You can think of ROS2 package as a building block of a robot application. For example, one package might handle a camera. Another package might control the wheels, another might perform navigation, and another could contain your robot or logic. Instead of putting one huge program in one place, packages help us keep the software modular, organized, and reusable. Today, we will create our first Python package called YT_PKG to understand the important files inside it and build it successfully. Before creating one, let us make the idea very simple. Our workspace is like the main project container. Inside the workspace, we have the src folder. And inside src, we have many packages. So conceptually, we have workspace, inside that packages, and inside packages, our actual ROS2 program, configuration, dependencies, and supporting files. This separation becomes extremely useful when robot applications get bigger. Imagine a mobile robot with 10 different functionalities. Instead of one massive project, we can divide those functionality into independent packages. We can then modify, build, test, or even reuse individual packages in another robot. ROS2 relies heavily on this package-based organization. Now, let us create our first package. First, I wanted to enter the src folder of our workspace. So let's enter cd YT_WS src. Now list the files in it. At the moment, it should be empty. So an important rule to remember: we create the packages inside the src folder, but later we build them from the workspace root. So that distinction will become very important as our workspace project grows. Now, ROS2 provides a command line tool specifically for package creation. The basic command begins with ROS2 pkg create. Here, pkg means package. For our first package, I will use the name YT_package. So that means YouTube_package. I recommend using lowercase names and underscores instead of making space. Now we also have to tell ROS2 what type of packages we are creating. For this course, we are starting with Python. We can also do it with C++, but we will just start with Python. So our complete command will be ROS2 pkg create space build type ament underscore Python space, can also say license page -2.0. So our package name is YT_PKG and dependencies dependencies rclpy. So let us understand this command before pressing enter. Now ROS2 pkg create means create a new ROS2 package, and build type ament Python. It tells the ROS2 that this is a Python package, and license page 2.0 records a license in the package metadata. Then we are using YT_PKG, it's our package name. And finally we are telling dependencies rclpy. So we are adding rclpy as the dependency. Generally rclpy is the ROS2 Python client library. It gives our Python program access to ROS2 functionalities, which we will start using when we create the notes in the next episode. Now, what exactly is ament underscore Python? This is worthy to understand. ROS2 uses ament as its build system framework. For a pure Python package, we normally use ament underscore Python. For a C++ package, we will commonly see ament underscore CMake. So when we specify build type ament underscore Python, we are essentially telling ROS2 create this package using Python package structure and build conventions. Python and C++ packages therefore do not have exactly the same internal structure. The important distinction is also this. Ament describes how an individual ROS2 package is structured and built. And colcon is the higher level build tool that discovers packages in a workspace and coordinates building them. So let me make it in a simple way to remember. For example, ament is how the package is built. Either it should be a Python package or C++ package. Whereas colcon, it will build the workspace and its packages automatically when you use the command called colcon. Now I press enter. So ROS2 automatically creates several files and folders for us. Let us check. So here it's creating different packages.xml and source folders, yt underscore package, setup.py, setup.cfg, and different folders and files are created. Let us type ls and you can see we should see this yt underscore pkg. So this package. Let us enter this package. So just go to this package cd to particular this, change the directory, and now again see the list. So there are quite a lot appending from the just one command. So this is one of the nice things about the ROS2. So we do not need to manually create a complete packages. So you can see the important things are licenses, package.xml, resources, setup.configuration, setup.python. So everything is set up. So inside the folder. And at this point, I strongly recommend installing Visual Studio Code. So if you have not already done so, you can use any editor you prefer, but Visual Studio Code is extremely useful. So when working with ROS2 and Python, because we will soon be navigating multiple files, writing nodes using Python extensions and working with larger projects. I normally open VS Code from the source folder rather than opening randomly individual files. So I will just go back to the source folder. So just type cd, the last folder, this is the source folder, then open the Visual Studio from here with a simple command code space dot. The dot means open the current directory. So VS Code now shows our entire source folder, including the YT packages. Now if you look at here, you can see the source folder with the YT packages. And this gives us the clean view of the project structure. Now let us look inside the yt underscore package. The first thing you will notice is another folder also called yt underscore package. So this inner folder is where our modules and later our Python ROS2 nodes will live here. Inside it already we have double underscore init double underscore dot py. So this file tells Python that this directory can be treated as the Python package. We do not need to modify it right now. So then we have a resource folder actually. And we also have the test folder. So like this, the test folder, resource folder. And there are some other important configurations files. You can see here package.xml file and setup.py file and setup.cfg configuration file. You do not need to memorize every file today. For this episode, the most important one is to understand the package.xml. Now open package.xml file. Now think of this file as the identity card of the ROS2 package. It tells ROS2 important information about the package. For example, we can find the package name here and version, description, maintainer, licenses. And dependencies, you can see the dependencies because we create our package with the dependency rclpy. You can also look at here the rclpy. Later, if our package needs another ROS2 packages, for example, message definitions or interfaces, we can declare those dependencies here as well. This is important because a package should clearly describe what it requires to work correctly. That becomes especially useful when somebody else downloads your project or when you move the project to another computer. Next, we have setup.py and configuration files, the both set of files. These files are particularly important for Python ROS2 packages. Setup.py contains Python packages installation information. Later, when we create executable ROS2 nodes, we will also use this file to tell ROS2 which Python function should become runnable commands. And setup.configuration provides additional installation configurations. For now, do not worry about every line. So when we create our first node in the next episode, the purpose of these files will become much clearer. Now we have created the package, but we still need to build it. And here is the important rule again: do not build from inside the package or from inside the SRC. Just open the terminator. You are in the SRC folder right now, but do not build it in SRC folder. Go back to the root of the workspace, okay, which is one step behind. That is, our workspace is yt_ws, this one. Now we can build everything inside the workspace using the simple command colcon build. So if you press the colcon build, colcon starts scanning the workspace and finds the ROS2 packages, and it determines how they should be built and then execute the required build process. This time, unlike in the previous episode, colcon should actually find one new package here, that is yt_pkg. Now it shows, you should see something like similar, starting yt_package, and then you can see finished yt_package. That means our first ROS2 package has been successfully built. Right now we have only one package, but imagine that later our workspace contains 20 to 30 packages. If I only modify one package, for example yt_pkg, I may not want to rebuild everything. It takes time, it's not intuitive. In that case, we can build only the selected package, so using the command. So instead of typing colcon build, so we can also do colcon build space package select. So we can use packages -select. So here we can specifically tell which package you wanted to build it. For this example, we have only one, so I can type yt_pkg. Now this is very useful command. Like, as project becomes larger, instead of rebuilding the entire workspace, colcon focuses only on the packages where we specify which package is updated or modified. Then we can only build that particular package. Now it's a quiz time. Pause the video and write your answers in the comment section. Question number 1. Where should you create a ROS2 package inside your workspace? Option A, in the build folder. Option B, in the SRC folder. Option C, in the install folder. Option D, in the log folder. Question number 2. Which command is used to create a Python package in ROS2? Option A, ROS2 new. Option B, ROS2 package create. Option C, ROS2 create. Option D, colcon create pkg. Now let's discuss the answer. For question number 1, the correct answer is B, option B, that is in the SRC folder. And for the question number 2, the correct answer is C, that is ROS2 pkg create is the command. That brings us the end of episode 5. In the next episode, we will create, build and run our first ROS2 node. If this video helped you, please like, comment, share and subscribe. Thank you for watching till here. Have a nice day.